Hey guys, so this is my submission for Lab 1, Constant Velocity. I'm going to be going through each of the lab instructions and explaining how I followed them. And in the process, I'm going to be talking about my observations. In the end, I'm going to be answering what if, what does it mean, and I'm also going to be talking about the assumptions I made in my model and some comparisons between my model and my observations. So let's get into it. First, I was asked to observe the motion of some object that is moving at the same speed without changing direction. Capturing the video of the motion and then analyzing the video using Tracker is the next step after that. So to do this, I first took a video of a soccer ball moving across my living room. Here's that video now. So there's that video, sorry that it's sideways. And then next I took this video and implemented it into Tracker. So this is that. When putting it, or this is not that, but this is that. When putting it into Tracker, I was able to extract some position versus time data and get the following table and graph. Um, yeah, some observations I can make about the data are the fact that the position versus time graph is actually negatively sloping. This is because my ball is moving from right to left. Uh, Next, we had to construct a computational model that accurately described my observations using this starter code. And the third step was comparing my model to my observations by plotting both my observed position and my predicted position. So they basically want the experimental versus the computational or the predicted. So to do this, I actually edited the web code that I was suggested to use and actually inputted my experimental data so I can show you guys what that looked like. I inputted my experimental data and then used a for loop such that for every data point, it plots it, and I can show you guys what that looks like right now. So as you can see, we have the green, which represents my computational model, and the red, which represents my experimental data. Some observations I can make about this are some of the roughness in the experimental data graph. It's not a completely straight line, and this is because of the non-ideal conditions that comes with almost any experiment. So then I'm going to talk about a couple of things. I'm going to talk about the main assumptions I made in my model to obtain good agreement with my observations. And then I'm also going to answer the two questions. So let's get into that. So the main observation that I had was that I had a downward sloping position graph because the ball was moving from right to left, which indicates a constant negative velocity. And some assumptions I made are that the initial push being an external force actually, kind of cancels out because of the frictional force. So what I said is, though the initial push is an external force that causes an acceleration and hence a change in velocity, I make the assumption in my model that the net force is zero throughout, which allows us to plot a constant velocity. The reason I make this claim is because of the frictional force acting on it, so I can kind of assume that those two are balanced out, but this is an assumption I made in order to make the lab graphing go smoother. Next, I'm going to answer the two questions. So the first question asks, when you analyzed your video data in Tracker, you made a choice of the orientation of the axes. Discuss briefly how your results would change or how they would remain the same if you were to flip the axes. And to this, I responded that if I were to flip the axes in Tracker, the direction of the velocity would change sign, but the magnitude and overall analysis of the motion remained the same. The ball would still appear to move at a constant velocity, but because the positive direction would be reversed to the negative direction, this wouldn't really affect our physical conclusions about the ball's motion. Velocity is a vector and has direction and magnitude, and flipping the axes simply changes the direction, aka the sign. So ultimately, the behavior remains unchanged since the ball's motion is uniform. The second question asks, your observations can be predicted well by your computational model when you set the net force equal to zero in your model. Is it possible for you to say how many pushes and pulls, i.e. how many forces are added together to give zero net force in the case that you observed? First, I want to talk about that with any experiment, there are unknowns and there are some sort of confounds. But I want to state that we can quantify the existence of at least two forces, and I'm going to talk about this in the paragraph. I said that since the ball rolls at a constant velocity, the net force acting on it is zero. This means that any forces acting on the ball, such as friction and maybe the initial push I gave it, are balanced out. In this scenario, there are at least two forces, the initial push that set the ball in motion and the friction that opposes the motion, which both sum to zero in our assumption, allowing the ball to maintain a constant velocity, in this case, a constant negative velocity for my soccer ball example. Because there are no unbalanced forces, the conclusion supports Newton's first law of motion, which states that an object in motion stays in constant motion unless there are external forces acting upon the system. That's the entirety of my lab report. I hope I was very clear in how I explained how I followed all the steps. Thanks so much.